Hello dear students, welcome back to my YouTube channel. Students, today we will start from question number 14. In this question number 14, we can see that it is asking why is plus minus butanol is optically inactive. Uh, Plus minus butanol is the equimolar mixture of plus butanol and minus butan to all in the equimolar quantity. When they are mixed together, then it will be called this plus minus butanol. Since it is a racemic mixture, for that reason it can't rotate the plane polarized light. Okay, for that reason plus minus butanol is optically inactive. I repeat it once again. Plus minus butanol is the equimolar mixture of plus butanol and minus butanol. For that reason it is a racemic mixture, thus it can't rotate the plane polarized light. So it is optically inactive. Now let's come to the next point, that is what are ambident nucleophiles. Explain giving an example. Okay. Now students, the ambident nucleophiles are the nucleophiles possess two or more nucleophilic centers, that is donor centers, but can use one donor center at a time. Okay, that is the nucleophiles possess two or more nucleophilic centers that is the donor atoms but can use only one donor center or donor atom at a time. For example, if we consider the Cn minus, the example is Cn minus. If we consider Cn minus, then Cn minus can use the carbon donor center or carbon donor atom or this nitrogen donor atom. Okay. For that reason, Cn minus is the example of ambident nucleophile. Another example is SCN minus or NO2 minus. All of these are the examples of ambident nucleophiles. Now let's come to the next question. Complete the following reactions. We have to complete these reactions. Now the first one is 1-methyl cyclohexene. When it reacts with HI, then here HI will be added according to the Markovnikov's rule. Thus hydrogen will combine to this hydrogen to that carbon. I repeat it once again. Hydrogen of this addendum HI will combine to this carbon and I will combine to this one in this way, CH3 I. Because here this hydrogen will combine, hydrogen is combining to that carbon with which the more number of hydrogen is already attached. Here one hydrogen is there, but in this carbon no hydrogen is attached. For that reason hydrogen is combining to this carbon and I is combining to this one. Now let's come to the next question, that is when but1ene is treated with HBr in presence of peroxide, then you will get 1 bromobutane, because here the anti-Markovnikov's addition will take place when it reacts with HBr in presence of peroxide. In presence of peroxide, then here HBr will attached or added to this double bond according to this anti-Markovnikov's rule. Thus, you will get CH3, CH2, 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 Br. Okay. Now let's come to the next one, that is when single bond C H double bond C H2, when that will react with HBr, that is styrene will combine with HBr, then here also this HBr will be added according to this Markovnikov's rule, but not according to the anti-Markovnikov's. Okay, thus you will get the hydrogen will combine to that carbon with which more number of hydrogen is already attached with. Thus you will get hydrogen will be attached to that carbon with which already more number of hydrogen is already attached with. Thus you will get this product. Now let's come to the next one, that is the fourth is not given here. What happens when CH3Br is treated with KCN and CH3Br is treated with KCN and AgCN. Okay, this is CH3Br. When it is treated with KCN, since Cn minus is the ambident nucleophile, for that reason here it will use the carbon donor center, thus it will produce CH3Cn. But if we use AgCN, then you will get methyl isocyanide. Okay. Now the next one is out of chlorobenzene and benzyl chloride, which one gets easily hydrolyzed by aqueous NaOH and why? Students, if we consider the benzyl chloride, then benzyl chloride will undergoes the hydrolysis easily. Okay, because if it will be treated with aqueous KOH, then it will form the resonance stabilized benzyl cation. Okay, now this benzyl cation is resonance stabilized. We can see that here resonating structures are possible. Okay, for that reason. But if we consider chlorobenzene will not react in this way, because the phenyl cation is unstable. Phenyl cation is unstable. Okay, so the answer of the question number 18, out of chlorobenzene and benzyl chloride, which one gets easily hydrolyzed? The answer is benzyl chloride. That is, benzyl chloride undergoes hydrolysis easily. Okay students, thank you. In our next class, I will explain from the question number 19. There have only 25 questions are there in this worksheet. Okay, thank you students.